Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Lisa Rosamina. I will tell you about probability. It is permutation. In permutation, I will tell about definition, types, and example problem. What is permutation? A permutation is a mathematical calculation of the number of ways a particular set can be arranged, where the order of the arrangement matters. In permutation, it is necessary to understand about the factorial. In mathematics, the factorial of a positive integer n, denoted by n factorial, is the product of all positive integers less than or equal to n. So, the rule is n factorial equals n times the difference of n and 1 factorial. For example, 4 factorial equals 4 times 3 factorial equals 4 times 3 times 2 factorial equals 4 times 3 times 2 times 1 factorial equals 4 times 3 times 2 times 1 equals 24. What about 0 factorial? 0 factorial is interesting. It is generally agreed that 0 factorial equals 1. Number of permutation on n different things that are at a time is the sum as different ways in which our place can be filled up with n given thing. It is denoted by small n capital P small r or capital P in brackets of small n comma small r, and then is given by permutation. R of n elements equals n factorial divide the difference of n and r factorial. Before going to types of permutation, let us know some basic about solving problem. 1. Find n if permutation 3 of n element equals 210. From the formula, we can write as n factorial divide the difference of n and 3 factorial equals 210. So, n times the difference of n and 1 times the difference of n and 2 times and the difference of n and 3 factorial divide the difference of n and 3 factorial equals 210. On cancelling the difference of n and 3 factorial on both numerator and denominator, we get n times the difference of n and 1 times the difference of n and 2 equals 210. Assume n equals 7. 7 times 6 times 5 equals 210. Therefore, n equals 7 is the answer. We can write the permutation in capital P in bracket small n, comma small r equals n factorial divide the difference of n and r factorial. Capital P is the number of permutation. Small n is the total number of objects in the set. Small r is the number of choosing object from the set. Types of permutation. 1. Permutation and different elements. In this type of permutation is used to determine the number of ways to arrange element by looking at the order. Mathematically, it is formulated as follows. Permutation n different element equals n factorial. Problem example. 3 books, namely economics, is called capital E, geography is called capital G, and history is called capital S, will be arranged in a row. Determine the number of ways to arrange these 3 books. Discussion. The following will describe the possible arrangement of 3 books in the problem. 1. EGS, 2. ESG, 3. GES, 4. GSE, 5. SEG, and 6. SGE. Based on the above arrangement, it can be concluded that the number of ways to arrange 3 books in a row is 6. Mathematically, the number of ways to arrange 3 books is 3 factorial equals 3 times 2 times 1 equals 6. Types of permutation 2 is permutation R of an element with 0 less than or equals to R less than or equals n. This type of permutation we are asked to no longer be as simple as a different permutation. Permutation of this element, the order is still considered, but the element must not be repeated. Mathematically, it is formulated as follows. Permutation R of n elements equals n factorial divide the different n and R factorial. Next problem example. A youth organization will elect a chairman, secretary, and treasurer from 20 members. Determine the number of arrangements they can choose. Discussion. Noun R is number of administrators equals 3. They are chairman, secretary, and treasurer. N is number of members equals 20. Ask how many possible arrangements. Answer. Based on the problem above, we can determine how many are and it is. Next, use the following permutation equation to find the number of possible arrangements. Permutation R of n element equals n factorial divide the difference of n and r factorial equals 20 factorial divide the difference 20 and 3 factorial equals 20 times 19 times 18 times 17 factorial divide 17 factorial equals 20 times 19 times 18, so equals 6,840. So the number of arrangements for electing a chairman, secretary, and teacher is 6,840. Next, types permutation. 3. Cyclic permutation or circular. Cyclic permutation is used to determine the number of ways to arrange different elements in a circular condition. Mathematically, it is formulated as follows. Cyclic permutation equals the difference of n and 1 factorial. Circular condition in question can be a circular game, sitting position a circle, the position of feet and a bracelet, and others. Problem example. 4 children, namely Andy, Bonnie, Cindy, and Dodie, will sit in a circle. Determine the number of possible sitting sequence. Discussion. Based on the unknown n equals 4, Andy, Bonnie, Cindy, and Dodie. To determine the number of possible sitting sequence, we can use the cyclical permutation equation, which is as follows. Cyclic permutation equals the difference of n and 1 factorial equals the difference of 4 and 1 factorial equals 3 factorial equals 3 times 2 times 1 equals 6. So the number of sitting order for the four of them is 6. Steps of permutation for permutation with the same element. Permutation with the same element have a characteristic in them is the same element or element must not be used for more than once. Mathematically, it is formulated as follows: NPR1, R2, R3, R4 until Rn equals n factorial. Divide R1 factorial, R2 factorial, R3 factorial, R4 factorial until Rn factorial. Problem example. Determine the number of words that can be arranged using the word physics, PHYSICS, with provision. The same element must not appear more than once. Discussion based on the data. In the problem, there is the word physics, PHYSICS. We must determine the number and quantity R1 equals S equals 2. Next, use the same element permutation equation to determine the number of ways that can be used. 6p2 equals 6 factorial divide 2 factorial equals 6 times 5 times 4 times 3 times 2 factorial divide 2 factorial equals 6 times 5 times 4 times 3 equals 360. So the number of ways that can be used to arrange the word physics is 360. Last steps of permutation is repeated permutation. In repeated permutation, the order is still considered, but the element may be repeated. Mathematically, it is formulated or follows P n equals n to the r. Problem example. Determine the number of three-letter arrangement of the word monster, MONSTIER. Discussion based on the data in the problem. Not n equals 7 and r equals 3. To determine the number of three-letter arrangement of the word monster, use the following equation. P7 equals 7 to the 3, or 7 cubed equals 343. So the number of ways to arrange three letters from the word monster is 343. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.